see. So as I said, in computer architecture the RAM is your main memory. Okay, so this is the cache memory. In cache memory, as I said, whenever we need cache memory because we need all our information instantly, so we don't need to, let's say 5, 20 and 21 is there in the main memory. Okay, you are constantly asking 5 every time, like today you are asking I need 5, again tomorrow 5. So instead of assessing it many times, like many times, so first time it will assess because our cache will be empty. So first time it will assess and it will store 5 in the temporary memory, and whenever next time you will ask the same number, it will not go and access the main memory, rather it will access the cache memory. Understood?
Instantly.
Yeah. So that's the point, because it takes longer time to access to the main memory and it takes faster to access
Well,
to the
explain
cache
these three
memory.
types.
Yeah. So basically the way we copy down the information from main memory to the cache memory has three ways. One is called direct mapping, second is associative mapping, and k-way associative mapping. So there are three mappings. Mapping is the way how we copy down the data from the main memory to the cache memory. Okay, see, so in exercise A, if you look here, we had 16 bit, one word is 16 bit, so it is a direct map cache. So it has 4 lines, that means 4 lines given means you will draw 4 rows, 1 2 3 4, like index index 0, index 1, index 2, this row is index 2 and this row is index 3. And then you will what is the total number of bytes given? 8 bytes. So you will either convert 8 bytes to bits, okay, which is 64 bits. So you will find number of words is the total number of bits divided by how many bits each word consists of. So each word is of 16 bit, you will divide by 16 and you have 4 words. So 4 words means you will make 4 columns. Then you will write number of hit, number of miss. Okay, what is number of hit and number of miss? Number of hit is the, let's say there is 5, 20, 21, 5, this is 20, 21 in the cache, and again you assessed 21. Since 21 is there in the cache, you will not go to the main memory to check the information. So this is a hit. Okay, let's say 6. See, not 6, not here, but 6. You are searching for 6. 6 is not there in the cache, so it is a miss. It is a miss. Whatever thing which is not there in the cache is a miss.
These
Yes.
data you chose them.
I randomly wrote to explain you the concept of
Okay.
miss and hit. So hit is the thing when we use the number of hit when we have the information in the cache, and for miss, whenever we don't have the information in the cache, we go to the main memory and access
Number
it.
of hits
Yeah,
and miss.
number of miss. So then you will do what you will do is, like, you have to draw see, now you have to look at this one, you have to draw this one. Okay, so you can skip it because in the exam you will have the question paper, so no need to do directly in the question paper, you can manage to do this. So this is the RAM data, which is 16 bit. So first call me 0 into 0 0 0, 0 into 0 0 1, 0 into 0 0 0 2, 3, has a very important concept here. I'll tell you. 0, 0, 0. Not 10, sorry, not 10, A. Then B. Then 0 into 0, 0, 0, C.
This is called
0,
BCD.
yeah, BCD code.
BCD.
I will tell you. D. Then 0 into 0, 0, 0. So 0, 16 bits means it will go from 0 to 15, right? So E. Then last will be F. So it is given, this will be given, this table will be given to you. Okay, so what are the values? Call me the values. This values
610.
610, next 33, 77, 90, 11, 21, 12, then 34, 34, then 6, then again 34, then 8, 32, 8, 32, then 75, 343, 23, 240. Okay, done. Now you look here, no need of looking there. See, in the cache memory, how many rows we have, how many columns we have? 4 columns. So you will divide it into 4 sections. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Done. So make it 4 sections because you have 4 rows.
No,
4 columns.
Columns are represented
Yeah,
by
columns. So you will make 4 sections.
okay.
Then so now you will start doing the question how you do. So you will write number of INS instructions. You will make a table. How many registers are there? R0, R1, R2, R3, R4, R5, R6 up to R7. So what is the work of these are called registers. What is the work of registers? Let me explain it to here. Registers, they store values. So the work of register is nothing but it will just store the values. Okay, see here it has stored R0 has stored 42, R1 9. So different registers have different values. Okay, so I am drawing it here because I want to make you understand. So number of INS, you will make a column like this. Okay, you will make it a section. In the copy you will make it like this. Then you will make R0, then R1, then R2, then R3, then R4, then R5, then R6, R7. So 7 registers. So you will make 7, you will write up to here. Then you will start drawing the lines. Okay, now it is better. I can draw the lines. Make the sections. Okay, so you have to make sections for like this. Okay, these things actually they have to be done in Excel file, but since we are doing it in the copy, so we are making sections.
And during the exam, should I write
No, you have to do the same thing. What I am doing here, you have to do the same thing. So what are the values of register? Just say me.
42,
9, 7, same.
6, 13, 17,
13,
1,
17, 1, 42. Okay, so you will copy down the values of register here. Understood? Whatever value is given initially. Now come to the, this is called the instruction. This is the instruction box. I will tell you. So what is first instruction? You will name it as 1. Then LD. LD means load. Okay, load, you will write LD R0. What is it then? R2. You will write like this, LD R0 R2. So what is LD? LD is load. Load means get the data from main memory to cache memory. Okay, get the data from the main memory. We copy down the data from the main memory to the cache memory. Okay, how will you do this? So first instruction is saying load R0 R2. So load the value of R2 in R0. This means, so what you will load, you will write m of memory of, since you are taking, so memory of what is R2 value 7. So m of 7 is equal to, you will go here, you will go here, where is 7? This one 7, right?
Yeah.
So what is the value here? 34.
34.
So m of 7 is 34. You will simple copy down. Okay, don't look there, look here only at this. Okay, so since we went, let me recap you. Load R0 R2 means load the value of R2 in R0. You will go and check what is the value of R2 here. R2 is 7, so you will write m of 7 is 34. How did you know m of 7? You will write m of 7. Okay, and then you will go to the main RAM, that is the main memory. You will search for 7. This is the 7 address line, and what is the value it has? 34, right? You will copy down the value and write 34 here. Understood? Okay, the work is not finished. Since our cache is empty, right? Our cache is empty. So since it is a direct mapping cache, first index will be copied in the first index, second, like first row in the first row, second row will in the second row, third row. So there is, since 34 is not there in cache, so it is a miss, right? So at 1, see, at instruction number 1 we have a miss, so I will write here 1. Okay, then rest of the things I will keep, but 34, it is in the second row, right?
34.
First,
Yeah,
second section, you will come here is second section, and which last end? 34, so you will write 34 here. But in direct mapping we copy down the whole section, so we will copy down 11, 21, 12, 34, everything you will copy down. 11, 21, 12, 34.
This is direct mapping. You copy
Yeah.
the whole row into.
Yeah. Why didn't I copy in the first index? Because I had a miss in the second index, right? This is index 0, index 1, index 2. Accordingly, 1 will be pasted in the 1. Sorry, 0 will be pasted in the 0. Let me explain you by rows. Let's say this is first row, this is second row, third row, fourth row. So first row will be pasted in first row. This section will be pasted like this. This will be pasted like this. This is called direct mapping. Okay, understood? Okay, since we had a miss in the second section, we will copy down the whole second section and paste it in the second section. Okay, so we have a miss here, and also you will mention 1 there because we had a miss at 1. Okay, next we finish this. Next instruction is look here, INC R2 it means increase R2 by 1. Let me write, INC means increase. Okay, so you will increase R2 equal to, so increase R2 means R2 is R2 plus 1. R2 equals to R2 plus 1. So what is R2 here? 7. So you will copy down 8. Just increase by 1. Third, see, come here, I will explain. Decrease R3. You will come to R3 will decrease by 1. It's 6 and it will become 5. Understood?
Yeah.
Next instruction, what is that? BRZ R3. That means is R3 0? BRZ R3 means BRZ R3 means is R3 0. see Z means 0. So is the value of register R3 0? Go and check. Is it 0?
No.
5. So you will write a no here. Okay, so 5. Next instruction, what is saying? Next one, load R1 R2. So load the value of R2 in R1, right? So where is R1? R1 is here. You will write m of, what is the value of R2? It's 8, updated, not 7. So m of 8 equal to, you will go here. Where is 8? 8 is this. So this one, 8 is this. So is this 6 there in the cache? No. So what you will do, you will copy down the whole section, 6, 34, 8, 32. Since it is in the third row, you will copy 6. What was the value? 6, 34, 8, 32. 6, 34, 8, 32. Okay, and it is a miss. You will name it as at what? 5, I think. Yeah, at 5 we had a miss, so you will name, you will write 5. Okay, so what was the value? It is 6, I think. The value is 6 at 8, so you will write 6. Okay, m of 8 is 6. Then next instruction, tell me the next instruction.
Sub.
6. Yeah, sub means subtract. So R4, see, sub R4 R1 R0, that means R4 equal to R1 minus R0. Sub means subtraction. So R1, simple, put a minus here and equal to here. So R4 is R1 minus R0. So where is R4? Here. What is R1 value? R1 is 6, R0 is 34. So 6 minus 34 is equal to how much? Minus 28, right?
Right.
So okay, let's copy down rest of the values here.
Write this in R4. Okay.
Because it is saying R4 equal to R1 minus R0.
Subtract.
So you will subtract the value of R1 minus R0 and store it in the register R4. Understood? Okay. Next 7. Next, what is the instruction? Tell me. BRN. BRN means is, okay, BRN R4. It is said, okay. See, BRN R4. It means is R4 negative? Is it negative? See, so what is the value of R4? Minus 28 here. If you see here, this is R4, so it is minus 28. Yes, it's negative. Yes, you will write yes. Then no need, just you will check whether it is negative or not. Next instruction, tell me. Move. Okay, since it is negative, there is a 2 written here, right? That means you will jump 2 steps. 1, 2. You will come to this instruction. Instead of writing move R0 R1, you will write, next instruction will be JMP. What is written? R6. See, you are at BRN R4. So BRN R4 is R4 negative? Here minus 28 value was stored.
Yes.
So yes, R4 is negative. So since it is negative, since this instruction is followed, okay, you will jump 2 steps. 1, 2. Next you will jump to the,
Why this 2? Why the jump?
it can say 3, 4, 5, 7,
This is
whatever
given, like-
given, it will be given. Your duty is to blindly follow the instruction and perform the operation. Okay, so 1, here you were, so 1, 2, you will jump to 2. This is 2. So jump R6, you will come to jump R6. What is R6? 1, right? R6 is 1. You will, okay, nothing. Next instruction, where we will not go to the move part. Since R6 is 1, I am writing yes. Yes means we have to go to the instruction number 1. See here, this is 1, this is 0, 1. So you will start the next instruction from 1, like a loop. So what is the instruction here? INC, increase R2, R2, increase R2. So R2 is this one, right? R2. So R2 will become 9 now. It was 8 before. So you
start
next
from the
again you will keep on doing it. Tell me like now.
So
Tell me
why
faster.
you jumped from here? Jump R6.
Okay, jump you in. Okay, you could have move R0, R1, right? But since our R4 is negative, so we follow this instruction. So if it is yes, then we will jump 2 steps.
Two
So
steps.
1, 2. 2 is
Jump.
this instruction number 8.
Jump R6.
So jump R6, you will come. What is the value of R6? It's 1.
1.
So obviously this is yes. I wrote a yes, that means we are going back.
1 is why this 1 is yes.
Already the value is
Oh,
there.
okay.
So
One.
yeah. So you will go to instruction number 1. So now you will not start from 0 or this one, you will start from this. So I wrote increase R2. So increase R2, then decrease R3, R3. So decrease R3, it's 5. This will be 4. Okay. Then tell me the next instruction, 11. Tell me the next one after decrease. DRZ R3. So is R3 0? 4.
No.
R3 is 4.
No.
So no. Then next instruction, load R1, R2. So load the value of R2 in R1. So what is the value of R2 here? 9. We have updated. So at R1, this is R1, M of 9 equal to, let's see what is M of 9. So at 9:34, already this section we had copied in the cache. So this is 34. We will copy down the value. M of 9 is 34. We will write 34. Okay. Then since it is a hit, since the information is there in the cache, so there is a hit. Add instruction at which number? 12. So you will write 12. Okay, got the point? Then 13. Next instruction, tell me the next instruction after load, then sub. You have to tell me faster.
Sub
R4
subtract
equal
R4.
to R1 minus R0. So subtract means R4 equal to R1 minus R0. So what is R1? R1 is 34, R0 is 34. So R4 is this one. Yeah, R4 will store 34 minus 34 is 0. I am directly writing 0.
Yes.
Okay. Let me copy down rest of the values also. What are rest values? Always keep on copying down the value so that you don't have to go up and check. 34, 34. This is 9. This is 4, right? Or this is 0. And this one 17, 1, 42. 17, 1, 42. Now you can keep on writing. Next 14. Tell me the next. If you are feeling cold, you can decrease it. You
I
can
don't know how. Okay.
put the plus up to 24 or 25 you can press on the plus. Yeah. Then after sub, then BRN R4. So is, see, this is R4. R4 is 0. Is it negative?
No.
No. So you will say no. That means you will not follow this. Okay. So what you will follow, since you are not jumping 2 steps, the next step is this.
MOV.
So 15 is move. MOV means move. Move R0 R1. That means, let me write, MOV R0 R1 means move the value of R1 to R0. R1 to R0. So what is the value of R1 here? 34. This is
34.
a 34. So we will move the value of 34 to R0. Since if R0 would have been 5, let's say, if, So we will copy down what is the value of R1 here, 34. So we will write 34 here. Okay. Since our R1 and R0 are same values, since they are same, so nothing. You will just copy down the value of R1 in R0. Okay. Then 16. Tell me the next one. JMP. Jump R6. Okay, so jump R6, that means R6 value is 1. Okay, now you will jump. Yes, I am writing yes, we will jump. So 17 again from instruction number 1. So INC increase R2. So R2 will become 10. Okay, R2 was 9, so it will become 10. 18. Next, decrease R3. So this is R3 will become 3. Then tell me the next. BRZ R3, right?
Yeah. Okay. Is it 0? No.
Is R3 0? No. Then 20. Tell me the next one. Load R1 R2. So load the value of R2 in R1. So this is R2 value 10, which is, so I am storing it in R1. M of 10 equal to, so I will write in R1. So let's go to 10. So 10 is this. We have already copied down the value in the cache. So it is a heat at 20 instruction. So I mentioned it heat. So no need to. What is the value? 8, right? 8. So you will write M of 10 is 8, the value. And at 20 there is a heat. Okay. So this is a heat. 21. Tell me the next one. Sub R4 equal to R1 minus R0. So at R4, R1 is 34. Sorry, R1 is 8. So 8 minus 34 minus 26, right? Am I correct? Yeah.
Yes.
So again we have to draw again the same things. Again in the next page, number of INS, because I have to continue.
Yeah.
So
this is like a loop. I mean, you can
loop. Loop.
So
but it will end. It will end.
Very big table. I mean, how should I like?
3 pages, 2 pages it will take. Like 2 pages, I think is enough.
This is the only first bit. This is the one. Okay.
After doing this, you will get to know what you are doing. R5, R6, R7. Let me keep. Basically the point is like you have to draw the table. I can directly determine from the, like from seeing from the 2 cycles, I can get to know how many cycles will be there. See, since it is your first time, I am just making you do everything you can do, but you have to do like this in the exam. Okay, so what were the values? Just copy down the values, previous values. So R0 was 34. See, this is R0. So R0 is 34. R1 was 8. R2 was 10. This was 3. This was minus 26. What was this? 17. 142. So R5 17. This is 1. This is 42. So next instruction will be 22. Next instruction. So after sub, so we were at sub, then BRN R4.
Is it negative?
Is it negative? Yes, negative.
Yes.
Because it is minus 26. Then 23. So since it is negative, we will jump 1 2. We will not do this instruction, we will jump here. So JMP R6. Yes, at 1, this is 1, so we will go to instruction number 1. So jump R6. See,
in R6.
Forget jump. What is the value of R6 here?
1.
So you will go to 1. Start again from 1.
Okay.
So INC R2 R2, increase R2, R2 will become 11, right? Because it was 10. Next 25, tell me, decrease R3 R3, decrease R3 2. See, this one is decreasing, and after that 26 is BRZ R3. So this is it 0? No. Is R3 0?
Decrease R3 and R3 means
Decrease R3 by 1. What you are doing from here, what you are doing from the beginning, you are doing the same thing again. Decrease
Okay.
R3.
okay, decrease 1 R3.
Yeah. Now is BRZ R3. Is R3 0? No. Okay, 27. Load R1 R2. Load the value of R2 in R1. So at R1 I will write M of, what is the value of R2? 11.
11.
M of 11. So go here, check what is M of 11. So this is A is 10, this is 10, 11. So this is 11. So 32. It's a hit or a miss? Tell me. This section we have already copied here, 32.
We have 32
So
here.
there is a one more at what? So what is it? 32. So let's write this 32, and at 27 there is a heat, right? So you will name it 27. Keep on writing, okay? Did you
27.
understand how it works?
Yes.
Then after doing this, next instruction, after load, sub R4 equal to R1 minus R0. So where is R4? This one. So R1 is 32 and minus, so it is minus 2. Okay. Be fast, like catch faster. Don't be so slow. Then BRN.
Is it
BRN
negative?
R4, yes, negative, right?
Yes.
Then since it is negative, what it will be the next instruction? BRN R4, yes.
Yes, to
Jump
jump
to.
to
Then jump
jump R6.
R6. So R6 has value 1, right? This is R6. Huh? Very bad line. Yeah. So R6 has a value 1. So it will go to 131. So again from 1. INC, increase R2 R2. Right? Be in line, don't ask me after long time. So again 12, 11, it was 11 before. See.
Okay.
So next one will be decrease R3 R3. So decrease the value of R3. R3 was 2, now it will become 1. Okay. Next 33. Tell me the next one.
Is it 0?
BRZ R3. Is it 0? No. So 34. Next load R1 R2. So load the value of M of 12 is equal to, so go here, 12, this is 10, 11, this is 12, so C is 12. So this value is not there in the cache because see, not there, so it is a miss as instruct. So 75 we will write M of 12 is 75. At instruction number 34 there is a miss, so at the column miss I will write one miss, and I will copy down this value 75 343 23 240. 75 343, what was that, 23 240, 23 240. Okay, copy down and come here. So you named, first you will go and check whether it is there or not. If it is not there, it is a miss, you will name it at which instruction there is a miss, and if it is a miss, obviously we will copy down the values here. Since it is a direct mapping cache, so fourth row will be copied in the fourth row, third row will be copied in the third row, second row will be copied in the second row, and first one since we didn't have a miss in the first row, so we didn't copy the value here, right? So we left that place. Okay, then this is next instruction. Tell me the next one. After load, we were
That's
here
stop.
again, the stupid thing.
R4
So
is
R4 equal to R1 minus R0. So R1 is 75, R0 value is 34. So let me copy down all the values. This one is R4. So 75 minus 34, how much it is? 1. This is how much?
30.
7. 31 it will be 513.
31.
Yeah. 31 no. 7 41.
41.
And copy down the rest of the values. 17 142, I think. Yeah, like write the values in one line so that in next instruction you don't have to search. 36. Tell me about the next instruction.
Is it negative? BRN.
BRNR4 so 41 is not negative, so no, I am
No.
writing.
So jump to.
So next one, so it is not negative, so will it follow this one?
Is
Yes
it
or
not?
no?
No.
No. Then next instruction will be
Move.
okay, perfect, move. If it follows, then it will go here. If it doesn't follow, it will start from here. So move R0 R1. So move the value of R1 value will move to R0 value. So what is R1 here? 75. So R0 will be 75. Okay. Then 38. Tell me the next instruction.
Jump. R6.
JMP R6. Again. So 39.
This is taking too long.
Yeah.
So this is really the answer.
Yeah, you have to. I will tell you when we will do. Increase next instruction, we are going to 1. So increase R2 R2. So R2 is 12, so it will become 13. Okay. Next, tell me the next one. Faster. Decrease. You should tell
Decrease.
me the next instruction.
Decrease. Okay. Decrease
R3
is.
R3. So R3 is
R3
now
is-
0.
Okay.
It was 1, now it is 0.
Is it 0?
So
Yes.
41. BRZR3. Is it 0? Yes. Right? Is R3 0?
Yes.
Yes. So follow this one. It is written BRZ R3 6. That means jump 6 steps. So you will not follow these instructions. 1, 2, 3, 4, 5, 6. We'll move to the last one. So the last one will be MOV R7 R0. So that what does it mean? Move the value of R0 to R7. What is the value of R0 here? 75.
75.
So it will move to R7 75. Done. Finish. All the instruction we finished. Okay. If you are cold, you can turn it that off for 5-10 minutes. It's okay?
Yes.
Yeah, see here, since we completed these things, okay, all our instruction we have to do it until we reach the end of the instruction. Okay, since we reached at the end of the instruction, why? Because see, BRZ is R3 0 when our R3 becomes 0. So we moved 6 jumps, so 1 2 3 4 5 6. We will only follow the last instruction and finish the loop.
When we reach the last instruction, it means it's finished.
Yeah, finish. It's
Okay.
finished. Okay. Now you will come to the question. This one we will do at the end. Okay. 1. Don't think of 1. Explain in what's the purpose of the program. You will do at the end. What is, look at the second question. What is the second question saying? What is the second question saying?
Indicate the value found in the register R7 at
So,
the end of the
End of the program execution. So at the end of program execution, execution. What is the value of R7? What is the value of R7? 75. You will write 75. 75 is the value of our register R7 at the end of program
here.
execution.
Can I see the whole map?
Yeah.
Okay.
Okay. Then come to the next question. Third, compute the total number of instructions performed by the program. How many total number of instructions? Starting from 1 to 42. So 42 is the total number of INS. Got the point? So easy. Then next one, compute the number of cache miss during the program execution. So cache, CACHE, cache miss, cache hit. Okay. So if you come here, see, if you come here, how many number of hit? 1, 2, 3. How many number of miss? 1, 2, 3. So you will write here 3 miss and 3 hit. Got the point? So easy after if you do like this. 5. Compute how many milliseconds are needed to access the total data. Like total time needed to access the data. Okay, for accessing the data means the information. So it can be two types. Either you have access to RAM or you have access to cache. What happened?
That's my link.
Okay. Okay. I think it's because of long time sitting. Yeah.
Yes, it's kind of. I've taken a walk from here, the university to here.
Oh my god. You should have taken a bus.
Yes.
Anyway, it's good. Okay. See, accessing the data means the information. Either you have access to the RAM whenever there is a miss, so you will access to RAM. Whenever there is a hit, you check the cache, right?
Yes.
Yes. So hit means the information is there in the cache. So we will not go and check in the main memory RAM. We will rather check from the cache and directly copy down the value from the cache.
If there is a miss, you
if hit, we copy from cache. If miss, we copy from RAM to cache. Like we look at the RAM, we take the information from the RAM and copy the cache the way we did. Okay. So what is the time needed for accessing the RAM plus time needed for cache? Okay. Come here. It is written the time to access the RAM is 60 nanosecond. So time to access the RAM, what is the time? 60 nanosecond. So since one time access to RAM is 60 nanoseconds, so how many times I have access to the RAM? Think. Don't look there. Look here. How many times I have access to the RAM?
What is the time to access the
RAM is 60. So one time if I will access the RAM, it will take 60 nanosecond.
Okay.
So how many times I have access to the RAM? Like how many times I have I have copied down from RAM. Three times, right? Why 3 times?
Yes, we have 3 hits.
3 hits. Perfect, yeah. Perfect. So 3 hits means 3 times. No, 3 miss. You told everything wrong.
Yeah.
So whenever there is a miss, you go to the RAM and access, right? Since the information is not there in the cache, so obviously where you will go? You will go to the cache and then access, or RAM?
There is not in the cache, so we have to go to the RAM.
Yes, perfect. So whenever there is a miss, we go to the RAM. So obviously 3 miss means 3 times access to cache, right?
Yes.
So so since we have for one time access to RAM is 60 nanosecond, so for 3 times it will be 60 into 3. One time is this much, so 3 times 60 plus 60 plus 60, it is 180 nanosecond. Okay, we computed for RAM. Okay, next, one time access to cache. See, read here, the time access to the cache memory is 12 nanoseconds. So one time access to cache memory is equal to 12 nanoseconds, right? So how many times have access to the cache memory?
3 times.
3 times. Why? Because we have 3 hits, so that means 3 times we have access to the cache. That means what you will do is like, so for one time it's 12 nanosecond, for one time it's 12 nanosecond, for 3 times it will be
36.
3 into 12, which is 36 nanosecond. So total time will be the RAM access time plus total RAM access time plus total cache access time, right? So what is the total value? So total time equal to how much? So it was 180 nanosecond and this one was 36. So 180 plus 36. So how much it is? 216 nanoseconds. But wait, it is saying to compute in milliseconds. So as you know that 1 nanosecond is 10 to the power minus 9 seconds, right?
Yes, nanoseconds.
216 nanoseconds equal to how much? 216 into 10 to the power minus 9 seconds, right or wrong?
Yes.
Okay. 1 second equal to 10 to the power 3 millisecond, right? Millisecond. ms, this is millisecond. 1 second equal to 10. Okay. 216 into 10 to the power minus 9 seconds equal to 216 into 10 to the power minus 9 into 10 to the power 3 milliseconds, right? So this will be equal to, I'm giving an arrow, that's better. So this will be equal to 216 into 10 to the power minus 6 millisecond. So this is your answer. Okay.
Here is.
Yeah, you found in nanosecond. Okay. Your duty is to convert in milliseconds. To explain you, I did like this, or else you simply could have multiplied it 10 to the power 3 to convert it. Okay, understood? Okay. This was okay. Let's go to the 1. We did 2, 3, 4, 5. So what is 1 saying? 1. Explain in words the purpose of the program. That means you have to explain everything what you did. So this load function, the instruction load helps to get the number of hits and miss, right? Hits and miss in cache, right or wrong? Tell me. Whenever we perform the load operations, it always help to get the number of hit or miss, right?
Yes, but by load you mean you put like, for example, R0 to R4 or R2 here?
Yeah, this both load. I'm talking about just load function. It can be R0 to R2, like R0 R2, and also it can be R1 R2. This both helps in getting the number of cache miss and cache hit, right? Yes. So you will write like this. Again, next. So basically we'll explain that increase R2. So if you look at the execution of the program, every time whenever we are increasing the value of R2, we get different, so accordingly our like R1 value is updated, right? If you see m of 12 is 75, m of 11 32, so you will write that this instruction increase R2 helps to update the information in R1, right? So increase R2 helps to update information in R1. Whatever you understood from the execution, you will do that. Tell me about decrease R3. Every time why we were decreasing the value of R3, if you see here, R3 was 6, then 5, then 4, then 3, then 2, then 1, then 0. This is like a loop, right? It is decreasing the loop. That means what you will write, R3, the decrease R3 helps to know the number of loops, the number of cycles. So decrease R3 helps to know the number of cycles. Okay, right or wrong? See, it was first 7, then 6. So 6, 5, 4, 3, 2, 1, 0. How many cycles? 6 to 5 is 1 cycle, 5 to 4 is 1 cycle, 4 to 3 is another 1 cycle, 3 to 2 one more cycle, 2 to 1 one more cycle, so total, then 1 to 0, so total 6 cycles. Okay, you can directly find the number of instruction. How you know? If you look at here, how many number of instructions are there?
10.
9? No, 10. No, you cannot find this 8 cycles.
You mean by instructions, you mean this?
Yeah.
Okay.
But if you see here, number of instructions, but some instructions we are skipping. So no, you cannot find like this. You have to follow this table. There is the only way, like proper way. If you follow the table perfectly, you will get the answer. Like the way we got all the answers, right? What is the value of R7 found?
Yes.
At register. What was
But
this?
you're
Everything.
explaining in words.
Yeah. Now at 1 you will skip it. Okay. First you will do this. First let me tell you. First you will draw the cache. Then you will write number of hit, number of miss. You will draw the two tables. Then this one no need to draw here, because you will have the paper here, so that you can make the sections, right? I draw here because I cannot make sections like this. I need to know that I have to make it sections 4 4 4 4.
Yes.
That's why I draw. Then these are nothing. I was just explaining you how what is the function of this. You will draw this table the same way I did. Then you will follow the instructions accordingly. Whatever instruction is given, you will follow this instruction. Follow till the end of the instruction, and then you will go here. These are the question. First one you will leave it. Second, start from second, third, fourth, 5. All you answer. Then you will go to the first one. Since you perform this program, you must know that what is happening, right? If you look at the load, every time whenever you are loading it, see, you are getting a value and due to this load function, like this instruction, we are getting the number of cache miss and cache hit, right? Because of load, we are going to check the RAM, main memory and cache memory. So you will write everything by words. So because of this load instruction, we check the information in the cache, in the main memory, and then if it is a hit, we copy down the value. If it is a hit, we copy from the cache. If it is a miss, we copy from the main memory to the cache memory, RAM to cache. Okay, then if you look at the next, like what R2 is doing, we are increasing the value of R2 like 10, 11, 12, and this helps to update the value in R1, because every time if you look at here, R1 is load R2 in R1, so we are loading the value of R2 in R1. So helping in updation of the
Increasing
value.
our
Yeah.
front-end loading.
So you will write helps to update the information in R1, right or wrong?
Right.
Yes. Instead of information, write value is better because our register stores values. So decrease R3, what it is doing, like helping us to know the number of cycles, like 6, 5, 4, 3, 2, 1, 0. Next, BRZR3, what it is doing, helps in terminating the loop, because if our R3 becomes 0, obviously it will move to the last instruction. So helps in terminating the loop, or terminates the loop is better. Terminates the loop. Okay, wait. This one rather helps in terminating the loop. This one also helps in terminating the loop or not? Helping in terminating. Yes or no? Because it was 7, then 5, then 4, then 3. So this one terminates the loop because we terminate and then go to the last instruction. And then what else you can get from information? Subtract. We just subtract and get values. And BRN R4, no, like move. Whatever is extremely important you will write, or else explain everything, your choice. I'm just explaining. Okay, jump R6. So jump R6 is important because it helps to start the loop. So basically jump R6 helps to start the loop because jump R6 is 1, so we again start from 1, right? So this helps to start the loop. And the last one, explain like all, I think. Move and this instruction helps to get the value of the last register, helps to get the values of the register. Okay, just explain everything.
Move helps to get the
Value of the register R7.
Register is a
Register is the storage element.
Okay.
Register is the element which stores the data, like store the value, like 82, 5, 6,
Okay.
just number values. Okay. Then is there, okay, this was the end of like exercise. See, we did everything. So next class we will do associated mapping. Okay, so
this
then,
was direct mapping.
yeah, next class we will do associated mapping. We have 2-3 questions. We will do that, but you have to be faster. Like this class was the first class, so next will be the same thing. There will be only changes in
yes,
this.
now my full focus is on like digital.
Yeah.
Okay, I will.
How to stop the recording? I don't know, it stopped or what happened. Okay.